Everybody, we're back. We are back, and I have been able to flip the screen. This is great. Okay, so heads up for those of you that are discovering this with me now. I just took my cover off my phone. Just a heads up, if you update your TikTok app, it seems like you cannot flip your screen. So that's interesting. Okay. Now I just got to get this thing to focus, and then we're good to go. Please share with your friends because we have lost our people, unfortunately. Okay, we back. We back, everybody. Thank you so much for being patient with me. As we all know, technology is an absolute blessing in our lives. I mean, it allows us to do incredible things. Such as teach and learn on TikTok. However, it can also give us such problems. But anyway, the point is that we're back. Who's Alana? Okay, if you need to leave, that's okay. Don't stress, guys. I appreciate you for being here. Please, can you guys share? Please, can you share with your friends that I'm doing an intro to trigonometry? And I would really appreciate it if you guys could join and learn with me. We're doing a very basic intro. Okay, what grade is this for? It's for grade 10. Okay, it's for grade 10. So trigonometry. So a question that I get, of course you're allowed to screenshot, go ahead. A question that I get asked a lot as a teacher when I start every single section that I teach, whether that be geometry, whether that be algebra, trig, whatever. I get the question all the time, ma'am, why are we learning this? And trigonometry is actually a very cool section. It's a section which we can use in various fields to help us calculate certain things such as angles and distances. Okay, they use it in engineering. They use it when they build in architecture, in navigation. This is so important. Trigonometry is extremely useful. But what is trig? So trigonometry is the full word. So trigon actually stands for triangle. If you guys didn't know, it's Greek. And ometry, or this part of the word, stands for to measure. So we're measuring things in triangles. So basically what trig is it is the study of the relationship between the angles and the lengths of the sides of triangles. Trigon means triangle. Now, what mathematicians, very smart, very awesome people, did back in the day is they realized that for certain angles, so here I've got 30 degrees. For certain angles, so here I say 30, the ratios of certain sides, so one side to another side, stays constant for a given angle. So what I mean by that is if you look at 30, if I look at this is a little right angle triangle. It's very important for me to mention that we're going to be working in right angle triangles for now. Okay? Right? If I look at my right angle triangle over here, I've got a 30-degree angle here. If I look at the side opposite this angle, I've got a 1. If I look at the side that's opposite the 90-degree, I get a 2. So, what I need you guys to realize is if I take the side opposite the angle and I divide that by the side opposite, so opposite the angle, and the side opposite the right angle. Now, you smart people, what grade is this here, Fro? I thank you for the confetti. That is so nice. Thank you so much. Okay. Everyone on the live right now, what is the side opposite the 90-degree called? What is this side called? Opposite the right angle. Hypotenuse. So if I take the side opposite the angle, so opposite the 30-degree angle, and I divide it by the hypotenuse, what do I get? The side opposite the angle is 1. The hypotenuse is 2. I get a half. If I drew this to scale, which I did not because I can't find a protractor in this house to save my life, they're all at school. If I extend this over here, so all I'm doing is I'm extending this line here, and I'm extending this line here. Okay, I'm extending the lines. I measure that line now. Okay, it's obviously not drawn to scale. And let's say this line over here is also 2 centimeters. And I drop a perpendicular from there to there. And let's say I measure this line. So remember, imagine it's drawn to scale and imagine I'm measuring. Okay, that's 2 centimeters. Okay, that's 2 centimeters. Okay, that's 1 centimeter. If this angle is 30. Okay, this is 2 centimeters. Look at my angle. If I look at the side opposite, so now I'm looking in this big triangle now. Ignore the baby triangle. Look in the big triangle. What is the side opposite my 30? It is 2, right? So let's use my color. So opposite the angle for the big triangle. So I'm going to write here big triangle. So that's this one. Opposite the 30 is 2. Over the hypotenuse, here's a 90-degree angle, assuming that those lines are parallel. Okay, because I said they're perpendicular, they're parallel. What is the hypotenuse of the big triangle? Can anyone see? What is the hypotenuse of the big triangle? What is the hypotenuse? Yes, 4. And what is 2 over 4 equal, guys? A half. So I hope you can see. If I draw this to scale and I continue extending this line that way and that line that way, and I keep the angle 30 and I measure for each size triangle, okay, they're similar triangles, I will get the side opposite my 30 degree over the hypotenuse will give me a half. And the people, the mathematicians, called this a name. They said sine 30. Now look what happens. Sine, on your calculator, it's written as the shortened version, which is sin. Sine 30, my angle is 30. If I press equals, do you see that it gives me a half? Okay, that means if I have a triangle, a similar triangle to this one, bigger one, an enlarged version of this triangle, if I extend this line and I get this to be 6, this one over here is going to be 3 because the angle is 30. And that sign refers to the fact of the relationship of the opposite over the hypotenuse. Okay, that is where this comes from. I just wanted to show you the background so you're not just blindly learning things and not understanding where it comes from. Now, before we get into actual trig or the basics of trig, I need to remind you of a few small things. So you might be saying, ma'am, this isn't trig, this is Pythagoras. You need to understand the theorem of Pythagoras or be reminded of it, and you need to understand things like this before we can tackle trigonometry. Okay, so let's go over this. I am sure you guys remember. Please repeat. Okay, music is live. Don't stress too much about what I just said. I'm more trying to show you where the ratios itself come from. So why do we, and they just chose the name sine, cosine, tangent. I just wanted to show you that for every similar triangle, so if I make this triangle bigger and bigger and bigger, as long as it's drawn to scale and I measure it out correctly, my angle is 30 degrees according to my protractor, the opposite over the hypotenuse will always be a half for sine 30. It just works. Okay, and you can do the same. You can actually go do it yourself. So for those of you that are super interested in what I just said, what you guys can actually do is take a triangle, but you need to construct properly. And you need to make sure that this angle is exactly 30. You need to do your measurements, your construction properly, or it's not going to work. It'll be 3/6 if it goes longer, if I'm right. Yes, Casey, beautiful. And you can do it yourself and you'll see that if my angle is 30, the opposite side divided by the hypotenuse side, that ratio will always be a half. And that opposite divided by hypotenuse is called sine. It's a sine ratio. Okay. Pythagoras, I'm assuming you guys know this. This is grade 8 work, maybe even grade 7. I'm not sure exactly. Right. If you just joined, welcome. Please follow me if you've just joined. And remember to share with your grade 10 friends. Guys, this is grade 10. Yes, it is. It's grade 10. This is a revision of grade 7, 8, 9. But trigonometry, you start in grade 10. At least for government schools that work under the CAPS curriculum. Okay, theorem of Pythagoras, we're working in a right angle triangle always. And if I'm looking for the length of a side in a right angle triangle, so I'm looking to determine the length of AB, or I called it C over here. If I'm looking for this length, I'm looking for the hypotenuse. The hypotenuse is always opposite the 90-degree angle. If I'm looking for the hypotenuse, which is the long side, I call it, we add, we square this side, we square this side, we add them, and then to get this, we square root that answer. Okay? What about left angle triangle? Oh my gosh, Beast Boy. Oh my goodness. Is that the maths joke of the day? I haven't heard that one yet. Okay. If I'm looking for not the hypotenuse, so I call it the short side, then I'm either looking for this side or this side. They are not the hypotenuse. They are not opposite the 90 degrees. Oh, sorry. Then I need to minus. So I take the long side squared minus one of the short side squared, and at the end I square root, because remember, I don't want b squared, I want b. Okay, you need to know this. Okay, but we're not doing Pythagoras now. We're just revising. What I want to show you, another thing that we actually should probably go over, but I'll do it later. Let's just jump into some actual trig. Now, for those of you that did your investigation, are you going to do Euclidean geometry grade 10? Yes, I will. We're starting with trig at my school. That's why I decided, and I saw some people ask me to do trig for grade 10. Is this in the exam? It will be in your June exam, yes. Okay. So I had people ask me to do trig, but eventually I will do both analytical geometry and Euclidean geometry. I think at my school we're starting with analytical. I must just check my planner again. Okay, now, are you going to do quadratic equations for grade 9? Of course I will. Right, now, I'm going to block out the bottom triangle. Let's not get confused. If I look at the top triangle, I've got A, B, C. That's what I've decided to call my triangle. I can call it whatever I want. I can call it K, L, M. I can call it X, Y, Z. Whatever I want to call it, that's what it is. Okay. In my triangle, I've indicated that the right angle is angle ACB, this angle here, or angle C if you want to call it that. And then I've indicated that angle ABC, or angle B, is theta. Now, theta is just a Greek letter. Okay, it's one way that we can say an angle. So, you know, like when we calculate, and we use variables as our unknowns, we say x plus 3 equals 5. X is our variable. Theta is like our unknown for our angle. So theta, you'll see thetas. You will see something called beta. So this is theta. This is beta. It's actually written with a small b, but it doesn't matter. This is alpha. And then, not as common, but I mean, this is phi. Okay. Do you only teach core maths? Yes, unfortunately, I only teach core maths. Okay. So, if we look at my triangle, I want you guys to say, let's consider theta. Let's consider theta. If I look at theta, AC is opposite the theta. It's opposite angle B. That what I wrote there is angle B. Sorry. I know I squished it in there, so it's a bit difficult to see, but angle B. The AC, side AC, this length over here is opposite theta. Do you see opposite? Imagine theta had eyes. Let's draw eyes on theta. Theta is a little cute little thing, and theta is looking opposite him is this side. Okay. Can you please be my maths and science teacher? Well, I am your maths and science teacher. See, I'm teaching you maths and science. Okay. Then, hypotenuse. That one's easy, guys. The hypotenuse is always opposite the right angle. So it's always the easiest to identify. The hypotenuse is opposite the right angle. So I tell my students in grade 8 when we learn about Pythagoras is imagine that the right angle is pointing at the hypotenuse. Then, if you look at side CB or BC, however you want to say it, it is adjacent to angle B or adjacent to theta. So look where theta is. Opposite him is that side. Adjacent to him is that side. Okay. How will they ask this in exams? Ooh, variety of different ways. We will do an introduction to some of the ways now. This is just a very basic introduction. Okay. If we look at this triangle quickly, now I'm saying that the theta is by A. Adjacent is next to, right? Yes, exactly. Adjacent means next to. Guys, if you hear weird sounds in the background, it's my cats, and they're having a moment. So if you hear weird noises, it's just two cats play fighting, hopefully. Anyway, adjacent means next to. So, okay, if you look at angle A is now theta. This side is opposite A, and this side is adjacent to A, next to, and this side still is the hypotenuse. Okay, so the hypotenuse stays the same in both triangles because it's opposite the 90, but this is adjacent if I'm speaking about angle B. This is opposite if I'm speaking about angle A. Do you understand that difference? What are the two cats doing? They love each other, I promise. They just love to play fight, but sometimes it sounds a little bit more serious. They're good. Okay, trig ratios. So we're going to apply these in right angle triangles because obviously in a right angle triangle, I have my hypotenuse and I can apply trig when I'm either looking for an angle. So if I'm trying to solve for an unknown angle, or if I'm looking for the length of one of the sides in a triangle. So basically, I think someone asked this in an exam and someone asked this in the comments and they said, how will they ask this? So they could, for example, give you the length of this side and the length of this side. And then they ask you to find theta. Okay, so I'll show you how to do that. This is a summary of trig ratios. You guys can learn this. And if you guys have seen some of my summary videos in the past, you would have seen I do this. So sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. Okay. Now, a nice way to remember that is with this little thing. It's called so ka to and I'm pretty sure when you do this in class with your yes, I see someone commented that. Nice. When you do this in class, I'm pretty sure your teachers will show you SOHCAHTOA. So for those of you that have no idea what I'm talking about, so this means sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Ka, C-A-H, means cos is adjacent over hypotenuse. Okay? And toa means tan is opposite over adjacent. Right, so I hope that helps some of you to learn your trig ratios. And you 120,000% need to know those off the top of your head. Okay, it's not difficult at all, but just letting you know that it's something that you do need to know. This is another summary. I thought this was really, really cute. So if you look here, okay, if you look at what I've got here, we've got sine is opposite over hypotenuse. There's the S. Now, there's theta. Opposite theta is this. That's why I put a star there. The hypotenuse is this. Do you see that I can make like an S out of that? It's just like a little way of memorizing it. Cos is adjacent over hypotenuse. There's theta. Adjacent is over here, and hypotenuse is over there. For tan, there's my T. It is opposite over adjacent. I thought that this was such a cute way of learning that. This is simple, I know. I did say that it's going to be a very, very, very basic intro to trigonometry. So I do apologize to the people that are finding this extremely boring. It's just that I wanted to introduce it to people that have never heard about trig in their life. Hello. Again, she loved Tariq. Okay. Let's carry on. So here's a very basic example. If they give you this in a quiz, really cute and understandable. Oh, I'm glad you like it. Thank you. Okay. If they give you this in a quiz, and this is something that your teachers may give you as, can you post those tips? Of course I will. They may give you this as a start to trig. So it's a very basic exercise. They give you A, B, C. That is theta. That is beta. Remember, those represent unknowns. It's the angle. So that's angle C, we call theta. Angle A, we call beta. And angle B is 90 degrees. So this is a 90-degree triangle. 5 centimeters, 12 centimeters. First of all, determine the length of the hypotenuse. Now, that's very, very straightforward and basic. How would I do that? How would I determine the length of the hypotenuse? Remember, the hypotenuse is AC, right? The hypotenuse is AC. So you would go AC squared equals, now I'm looking for, yeah, some of you got the answer already. So I'm looking for the hypotenuse, I'm looking for the long side, so it's 12 squared plus 5 squared, and you write Pythagoras over here because I'm using Pythagoras. And I'm just going to skip to this step over here, 12 squared plus 5 squared. We get AC is 13 centimeters. So I'm going to write that into my picture, 13 centimeters. Okay, easy enough. Now, let's move on to the next question. We need to do some trig here. Write down the value of sine theta, cos theta, and tan theta. Okay, so sine theta. So everybody, you guys should be able to do this. Sine theta. What is sine theta equal to? Sine of your angle is equal to opposite over hypotenuse. You don't need to write that. I'm just doing it for you so you can see what's going on. Okay. What is opposite my theta? What is opposite my theta? Opposite, yes, theta. Opposite theta is 5. And my hypotenuse is 13. So sine theta is equal to 5 over 13. Right. I hope that makes sense. That's all the question asked me to do. All they wanted to, too fast, ma'am. I'm sorry. How do we write AB? What do you mean? Sorry, I'm just going back over comments. Okay, so you use the lengths and not the angles. So no, we are basically what we do in trig is we use ratios. Okay, so I'll go back to the previous page. Sine theta. So the ratio for sine of an angle, that, remember, sine just means it's a ratio, is opposite over hypotenuse. Okay, so sine theta equals opposite over hypotenuse. So all this question is asking me to do is write down the value of sine theta. In other words, what does sine theta equal to? It's not asking me what theta is. Okay, it's not asking me what theta is. It's asking me what is the value of sine theta. So what is sine theta equal to? So remember, sine theta is equal to the opposite side over the hypotenuse. So maybe I should just write it out for the first one. So I can't spell today. Opposite side. So when I say opposite side, grade 10s, I mean the side that is opposite the angle. So we want sine of theta, not beta. So look at theta and you look in your triangle and you say, okay, here's theta. Remember, draw the eyes on theta. And you say, if theta looks opposite him, what side is he looking at? His opposite side is 5. Okay. What is the hypotenuse in this triangle? The hypotenuse is 13. So 5 over 13. Okay. If they asked me to find the angle. So some of you are on here and I can tell this is boring for you because you've already done this. But remember, this is for grade 10s that have literally never seen trig in their life. Just trying to make them comfortable for tomorrow or whenever. Okay. Yay. I'm glad you guys get it. Okay. If, and that's not what the question's asking, but if the question asked to solve for the angle, how would I get that angle? Does anyone know? And you may use a calculator to solve for the angle. How would I get this angle that makes this equation true, essentially? How would you get that angle? Shift sign. Lekker. Well done. Shift sign. Okay, so watch. If I'm solving for an angle, what you do is you go shift, sine, the inverse, technically, and you go 5 over 13. Okay, shift, sine, 5 over 13, you press equals, and you get 22, 61986495. Now, I'm going to write that down. Theta, which is my angle, is equal to 22,61986495 degrees. Remember, it's an angle. Now, when you do this in the tests, you'll round off. Okay? Easy stuff for me, ma'am. Oh, I'm so glad. Okay. If you do this, you will round it off, but I'm trying to show you something now. If I press sine, if I take my calculator and I substitute my answer, 22,61, blah, 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 in the place of theta, let me show you. So I go sine, and in the place of the angle, I go 22,61986495, close brackets. Oh, yeah. Then you will get 5 over 13. 22,61986495 equals 5 over 13. Exactly. Lovely. Okay. 5 over 13. I don't know if you guys can see it. Okay. To think I'm struggling with this and I'm in matric, don't stress. Where did you get 22? Oh, that answer over there. You have to write. Sorry, I've missed a few comments. Trig, fun. Why don't you round off? No, you do round off. I was just showing you if I sub back in, what happens. So if I sub that answer back in, what happens? Like what does my calculator tell me? And it gives you the equivalent of 5 over 13, which is, I'll tell you in a second, 0,3846, blah, 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 5 over 13. Okay, let's move on. Now, you guys can try this one. This is grade 10. Let's do a different color now. Let's do purple. What is cos theta? Okay, we can all do this. Let's try. Believe in yourself. Thank you for the lesson. I have to go. It's a pleasure. Okay, cos theta. What is cos theta? Cos. What is my ratio for cos? Cos theta is the adjacent side. The adjacent side. When I say the adjacent side, I mean you look where the theta is and the side next to. And I know some of you might be saying, but ma'am, this side is also next to theta. This is the hypotenuse. This is opposite the 90, so this is the hypotenuse. So this one is the adjacent. Adjacent side over the hypotenuse. So what is the adjacent side? 12, right? My adjacent side is 12. My hypotenuse is 13. So if the question just says write down the value of cos theta, you leave it like that. Okay? Right. However, what is theta? Okay, theta, you spell it like this. Theta represents an angle. Okay, so it's an angle. If I ask you to find theta, so find that angle, we learned now that how do we do this? We go shift, we're trying to find an angle, shift, cos 12 over 13. Oopsie, you must close your brackets. Let me show you. Shift cos 12 over 13. There's your angle. Okay. Shift cos. Right. I'm going to skip to this over here. If they ask me to write down the value of, let's do tan. Let's skip to this question. Tan beta. Remember, beta is representing an angle. I'm going to write the answer here. Tan beta is equal to, what does my trig ratio look like? Tan beta. What is my trig ratio for tan? Tan is the opposite side. So opposite to the angle's beta. Opposite side over the adjacent side. Do you see here we don't include the hypotenuse in our tan ratio? Okay. Yes, you can use this for the GCSEs, Luke. You guys do trig as well. So in this case, let's look at beta, everybody. I need to move my page down. There we go. There's beta. Opposite over adjacent. Remember, 13 is my hypotenuse. It stays my hypotenuse, whether I'm looking at theta or beta. 13 stays my hypotenuse because it stays opposite the 90. Let's look at beta. Which side is opposite beta? The 12. Which side is adjacent to beta? 5. Okay, so tan beta is 12 over 5. Tan beta. So write down the value of tan beta. There it is. And in some cases, you can also, 12 over 5 is the simplified version of the fraction. If they were to ask you to write it to the nearest decimal, to round it off to 2 decimal places or to 1 decimal place, tan beta would be equal to 2,4. Okay, I see someone asking me to look at the comments. Can we get this on YouTube? I will definitely try and save it. Doc Babe Boo, do you have a question? Okay, please let me know. But since it's right angled, can't we use a squared plus b squared equals c? Okay, so yes, we used Pythagoras, is what you're referring to. We used Pythagoras to determine the length of my third side. So I knew AB and I knew BC. So I used Pythagoras to determine the length of this unknown side. But what these questions over here are asking me to do is they're asking me to use trig ratios to write down a value. Okay, so it's asking me to use ratios to write down a value. So remember, sine, cos, tan, all of those words just refer to ratios of sides. So for example, how did I get 13? Okay, I did that over here. I used Pythagoras. Okay, I used Pythagoras to get the 13. Okay, so what these questions are asking you to do is they're saying, write down the value of sine theta, of cos theta, tan theta. These fancy Greek words, all that they mean, this is sine, this is cosine, and this is tangent. These words are shortened versions of the actual words. There are just words that the mathematicians came up with to represent the ratio of sides. So sine will always, go back to my summary, sine will always be the ratio of the opposite to the hypotenuse, opposite over hypotenuse. Cos will always be the adjacent over the hypotenuse. And your value of sine or cos will differ obviously depending on the angle that we're talking with respect to. Okay, let's carry on. Okay, this question, example 2. Can we get this on your bio? I will try and scan these in as PDFs and upload to my bio. Okay. Right. In this example, I've got triangle MNO. Okay. And what I want you to do in this example is determine. So the question says determine tan N. Okay. In other words, I want the ratio. Okay. Okay, just give me a second. I see some people asking me, why is it 2.4? Are you guys talking about this question? Okay, beta, remember tan is opposites, opposites, opposite. So what is opposite beta? Remember, we're looking for tan beta. Opposite beta is 12. There we go, opposites. And then adjacent to beta, so adjacent means next to. So there's beta, next to beta is 5. So remember, there's beta, beta's looking opposite him is 12. Next to him is 5. And I know you guys are saying, man, but the 13 is also next to him. This is the hypotenuse. So it's 12 over 5. And what is 12 over 5? 12 over 5 is 2.4. Okay, do you guys see that? Let me know before I move on. Okay. Tan n. Okay, so here's n. Okay, here's n. This is my n. Tan n. Remember, n is essentially my angle, right? N is essentially my angle. So how do I do this? How do I do this? Let's go tan n. Let's actually say that this is, I'm just going to say that there's a theta here. So tan n is tan theta. Let's just call it theta. That's my unknown. Okay. Now, I don't know if you guys can see the problem. Not problem, but the issue, not issue really, but what we have to do first. What is my ratio for tan? Tan is opposite over adjacent. Now look at my n, my angle n, because they want me to determine tan n. Or theta, I called it theta. What is opposite my theta? MO. Do I have a value for MO? Do I have a value? No, I don't. I don't have a value. Ooh, oh no. So I'm going to put a question mark there for a second. However, what is adjacent to my theta? Now be careful. Is the 9 my adjacent or is the 15 my adjacent? Yes, first we're going to find the length of MO. You guys are correct. We're going to use Pythagoras. Yes, the 9 is my adjacent. Okay, so I just want to make that very clear. My adjacent, before I find MO, my adjacent, here's my angle. It's the one next to, it's the 9. The 15 is what we call the hypotenuse, remember? Hypotenuse. How do I know that that's my hypotenuse? It's opposite my right angle. So it would be tan theta would be MO over MN. I can fill that in. This isn't a necessary step, but what I want to do to show you is we don't know MO. How do I calculate MO? Do I have a right angle triangle? Yes, I do. I have a right angle triangle. I have two sides, two lengths. So can I find MO? 100%. I can use the theorem of Pythagoras. I'm looking for MO. So MO squared, that's the side I'm looking for, equals my hypotenuse squared minus MN squared. And remember, you need to write Pythagoras in brackets. No reason, no mark. MO squared equals 144, if I'm not mistaken. So MO, what's the opposite of square? Square root, the inverse. So it is 12. So MO, I found out to be 12. There he is, 12. Now I know that tan theta, or tan n, whatever, is equal to 12 over 9. And should I leave it as 12 over 9? No, I can simplify. What is 12 over 9 in its simplest form? 4 over 3. Okay, there we go. I'm not going to do the next one into too much detail because I want to move on, but cos n. Cos is adjacent over hypotenuse. So if I look for cos n, adjacent to the n is 9 and hypotenuse is 15. Okay, so you guys should know how to do that. Another easy thing that I want to go over with you. Why does this look so easy? Keisha, it is really easy in the beginning. Trig is really, really easy. I wouldn't say really, really easy. It is relatively easy in grade 10. When you get to grade 11, it's a little bit more interesting, I would say. But if you enjoy this section, you will find it, you will love it. Okay, so calculate trig ratios of a given angle. This is super easy. And for now, I'm going to show you how to use your calculator. However, and this is a big however, when you learn special angles, which I hopefully will show you in this video, and they ask you to calculate the value of trig ratios, calculate the trig ratio of a given angle using special angles without using your calculator, then you need to use your triangles. And you cannot use your calculator. However, in this exercise, I'm telling you to use your calculator. You make me love trig. Oh, I'm so excited. Yay. Okay, so this is very easy. So let's show you quickly. Cos 60. I just want to point out that if I open the bracket over there, my calculator immediately opens it up for me. I have to make sure to close it myself. Press equals. It gives you a half. I mean, you can write it as 0.5 if they ask for it in decimal form to two decimal places. If I do cos 35 equals, let's round it off to 2 decimal places. Cos 35, 0.82. Remember, the trig ratio, this cos, sine, tan of an angle, this represents a value, and this is the value of that, 0.82, rounded off to 2 decimals. In this case, I've got 5 cos 60. 5 cos 60. It's basically 5 multiplied by cos 60, and I get 2.5, or 5 over 2. What about this one? Sine 35 plus 75. Sine, in brackets, 35 plus 75. Sine 35 plus 75. Sorry, I'm doing this out of screen. I'm being silly there. Sine 35 plus 75. 0.94. That's important. Guys, I just want to actually make a point here. Sine 35 plus sine 75. Essentially, we're first going to add these two together. 35 plus 75 is 110. So essentially, we want sine of 110. That's what we're doing there, okay? It is not the same. Sine itself, sine, the word sine represents a ratio of 2 sides. It is not a value on its own, so you cannot do distributive law. Sine 35 plus 75 is not the same as sine 35 plus sine 75. Do you understand that, guys? Do you understand? Okay. Why does the calculator have to be in deg mode? Yes, I wrote that there. That means degree mode. We are working with angles in degrees. Okay, so this is very important. And I have students that sometimes they do their tests. They're doing trig. And unfortunately, their calculator is not in D. Do you see the little D over there? It must be in degree mode. You can change it over there. Okay, in your settings. Okay, so I'll repeat it one more time. Sine brackets 35 plus 75. This is essentially saying sine of 110. It is not the same. Sine brackets 35 plus 75 is not the same as sine 35 plus sine 75. You cannot distribute. It's not the same thing. Okay. Ma'am, are you from South Africa? Yes, I am. Is my accent quite obvious? I always wonder that. How obvious is my South African accent? Okay, cos squared 30. That is the same thing as saying cos 30 squared, which essentially is cos 30 times cos 30. In this exercise, I tell you, you're allowed to use your calculator, so we do it like that. Make sure the square is outside the brackets, please. Okay, yes, because I'm also from the SA. Woo, awesome. Okay, now, very, 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 very simple trig equations. Do you see, in this case, in the previous exercise, I gave you the angle and I wanted the ratio, the value, okay, of the ratio. I gave you the angle. Here, I am giving you the value of the ratio, but I want the angle. We discussed this previously. When you are looking for an angle, what must I do on my calculator? Looking for, and over here, I'm not asking you to use special angles. I'm telling you to use your calculator. I'm looking for, I'm going to call it the angle. What must I remember to do? I must remember to shift cos. Okay? I must remember to do shift. So cos theta equals 0.5. So I do shift cos 0.5 equals 60. And when we do special angles, you guys will know this immediately. Theta equals 60 degrees. Next one, super easy. You're a great teacher. Thank you so much. I really appreciate that. Okay, tan theta equals 4,123. Shift tan 4,123. And I get theta equals, let's round off to 2, 76,37. If I ask you to round off to 2. Okay, do you do 7th grade to 9th grade maths? I'm not teaching 7th grade maths at the moment, but I mean 8th grade maths builds on 7th grade. So I do teach a lot of similar concepts. Okay. May I please ask if the live is going to be available? I will definitely try and make it available on my YouTube channel, which is Maths and Science with Miss M, if TikTok decides to save it, which hopefully it will. Okay. In this equation, I need to solve for theta. This isn't in my standard form. So, like we normally do with equations, I need to first get rid of the 2. How do I get rid of the 2? Make sure before you shift, you isolate first. Yes, 100%, doctor. 100%. Okay. So, how do I do this? I need to isolate. I need to essentially isolate sine theta. Yeah, I had cos theta isolated. Yeah, I had tan theta isolated. I need to isolate sine theta. This is multiply by 2. So I need to divide by 2. So 1,124 divided by 2 is sine theta equals 0,562. Now I've gotten rid of the 2. Now I do shift sine. Shift sine 0,562 equals theta equals 34,19 degrees. If I round it off to 2 decimal places. Have you done Euclidean geometry on my channel? Not yet. Not yet. Okay. Ooh, this last one. You can see I squished it on this page. So funny. But I will extend the page and do it properly. Okay. Let me write it. 1, so this is number 4. 1 plus 2 cos x plus 10 equals 2,356. Now, grade 10s, how on earth do I do this? Can I go and shift sine? Can I shift sine already? Heck no, I cannot. Why not, guys? Can I shift sine yet? No. I cannot shift sine yet. I need to get it into the proper form. I need to get it into the proper form. Okay? Thanks for the free lesson. It's a pleasure. Okay. So what do I do? How do I get this into the proper form? Well, I want to essentially isolate cos and my angle. This entire thing over here. This entire thing is my angle. This entire thing. Before, we've only seen sine theta, tan beta. This entire thing is my angle. So I need to isolate my cos and my angle. How do I isolate that? Well, I need to get rid of, thank you, my one nail broke, you can see. I need to get rid of the plus 1, the positive 1. I need to get rid of this here, this 2, this multiply by 2. We first need to get rid of the plus 1, guys. So what I'm going to do is I subtract 1 on both sides of the equation. Okay. So we've got 2 cos x plus 10, 2,356. Now I'm going to subtract 1. Which is 1,356. Okay? Then, am I done yet? Is that in my correct form? Can I shift cos this number over here? No, I cannot. What I need to do is I still have this little guy over here, this little girl, this little number this little pretty little number, number 2. Number 2 is my favorite number. So this is grade 10. What must I do now? I need to divide by 2 on both sides of my equation. Remember, equations is all about isolating, then we're going to solve. To isolate, we do inverse operations. So here, to get rid of the 1, the plus 1, I subtracted 1 on both sides. To get rid of the times 2, I divide by 2 on both sides. I get rid of it on this side. If I divide this by 2, 1,356 divide by 2, I get 0,678. Okay? Awesome. I subtracted it by 1,000. No. 2,356 minus 1 is 1,356. Okay? I did not subtract wrong. Then, what do I do next? Now, Dora D Z Z Z. I didn't get it wrong. Okay. Anyway, now I've got cos of my angle. Cos of my angle. If I have cos of my angle, I've isolated it. Now what do I do? My bad. That's a decimal place. Oh, that's a comma. Yeah, that's a comma. Sorry. I know that in certain countries that is used to represent thousands. So I'm assuming you thought that was 2,356. Sorry, it's a decimal. Why do you put a dot on top of the 10? Oh, it's degrees. This is part of an angle. Okay. So decimal as dots. Okay, I can do that from now on. What country are you guys from? In South Africa, we use commas as decimals. Anyway, I've got cos of my angle equals that. Now, remember, I'm trying to solve for my angle essentially x, right? I just want to show you guys because I feel weird now. Let me just get my textbook. There. We use commas. We use commas, not dots. But, I mean, everyone's different. There's no wrong and right. Okay. Anyway. Then we shift cos. Shift cos. Okay. Because I'm trying to find the angle. What I'm doing here is I've got cos of some unknown angle. Some question mark of an angle gives me that value for that ratio. Remember, cos is a ratio of an adjacent side over a hypotenuse side. So cos of some certain angle gives me that value, that ratio, that value for that ratio. So in order to obtain the angle, I need to do the inverse. So shift cos 0,678, and I get 47,312 blah, blah, blah. 47,312 blah, 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 4, no. And the angle, remember the angle was this entire thing. The angle is x plus 10. The angle was x plus 10. We use commas in South Africa. You're definitely right. Okay, but I'm not asking you to find the angle. So the angle, cos of this angle is equal to that. However, I'm asking you to find x. So how do I find x? Remember, this whole thing represents the angle. How do I find x? This is plus 10. I need to subtract 10. I get 37,3 or 3,1, depending on how you round off. Yes, subtract 10. How did you get that? How did I get what? Okay. How did I get 47? Okay, so what I did is, now that we've isolated cos angle, so cos of my angle, remember cos of my angle is a value. It's a ratio of sides, essentially. So now that I've isolated cos of my angle equals that value, I'm trying to find the angle. I'm trying to find what this is equal to. So if I'm trying to find what this is equal to, I go shift cos, why shift? Because I'm trying to find the angle. I don't know the angle. I know that, I know the value. of the ratios. I don't know the angle. So I go shift cos and I type in 0,678. 0,678. See, we even have commas on our calculators. Equals 47,3124. So the angle, x plus 10 is the angle. The angle is equal to 47,3124. And then to get x alone, I need to minus the 10. Okay, please let me know what you guys thought of that. Are you happy with that? You can definitely check your answer. So how you check your answer, so you go 47,3124. Okay, remember this is 3124, blah, 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 blah. To check your answer and check it most accurately, use as many decimal places as you can. We found the value for x. So to check to see if your answer is correct, you take your value for x and you substitute it in the place of x. So I go 1 plus 2 cos. Now x is that 37,3124, and there were more decimal places, but that should be fine, plus 10. So I'm just typing in close brackets. Okay, let me just check if I've closed all my brackets. Yeah. Equals, do you see there? It gives me 2,356. 2,356. Okay. So that you can check it. So you just take your answer, you put it back in the place of 10. Right. Now, the last thing that I'm going to do before I go, and I'm going to make it very quick because I am going a little bit over time, although we wasted about 5 minutes with struggling with my phone. I hate math. I'm so sorry to hear that. Okay, I'm going to just go quickly over special angles, and I just want to show you guys something. When you do trig, you're going to be expected to use angles, and those would be 30, 45, and 60. And you need to learn the ratios associated with those angles. Okay? And you will be able to then use those special angles. Ma'am, do you only do maths? I do physical sciences as well. You're going to be asked to use those special angles to answer questions without the use of a calculator. So if you look at these are called our special triangles. I don't know if any of you have seen this before. Comment down below if you've seen this. So special angles, right? They're referred to as special angles. And the reason why they're called special angles is because we can determine the trig ratios of these angles without needing to use a calculator. Will trig be taught in term 2 for grade 10s? Most likely. Okay. So they're called special angles because they enable us to calculate trig ratios of these angles. So 45, 30, and 60 without using a calculator, which is great. Okay. So special angles originate from these triangles. You need to learn these triangles. In this triangle, I've got a 90 degree, I've got a 1, and a square root 2. If that is 90 and this is an isosceles triangle. So if that has got a length of 1 and that's got a length of 1, we know angles opposite equal sides. Oopsie. So if that's 45, that's 45. If that's 90, that means that these two angles will be equal. So 180 minus 90 divided by 2 is 45. You can just learn this. Okay. You actually do need to learn this. This is triangle A. Then for triangle B, what they did is they took an equilateral triangle with sides of 2. 2, 2, 2. Then they dropped a perpendicular, cutting these into two congruent triangles. So I've got, if this is 2, and this perpendicular line is essentially like a line of symmetry. Ma'am, you so rudely ignored me. I definitely don't ignore anyone on purpose. I do it because I'm teaching, so I don't see all the comments. You only do high school. Was that your comment? Hard guy. Sorry, I just scrolled up to find your comment. You only do high school. Yes, I do high school. Okay. If I drop this, I divide BC directly in 2. So this is 1 and that is 1. If that's a 90 degree angle, this will be a 90 degree angle. So essentially, what we do, no, I definitely didn't do it on purpose. What we essentially do is I'm going to work with one of these right angle triangles. Because remember, we need to be working with right angle triangles to use these trig ratios. It works in right angle triangles. So I'm going to take from my ABC triangle, I'm going to use the 1 triangle. Okay, so to create this triangle, just to show you. Now look at what we've got here. If that's 1 and that's 2, okay, if that's 1 and that's 2, how do I find the third side? How do I find the third side? How do I find the value of this third side? What I do is I can use Pythagoras. This is the hypotenuse. This is what I'm looking for. If you use Pythagoras, which I'm not going to go into detail with, I get square root 3. So, guys, essentially, oopsie. Oh, also, if this is an equilateral triangle, just by the way, if this is an equilateral triangle, what is this corner angle in degrees? Yes, everlasting Stephen, exactly. What is that corner angle in degrees? If this is an equilateral triangle, you see we've got 2, 2, and 2. That is 60. Beautiful. What is that angle over there? 60. What would each of these angles be over here? So remember, I dropped a perpendicular, dividing this into 2. So this would be 30 and 30. Remember, what I've done to look at this triangle over here is I've extracted this triangle. So this is 60 and this is 30. I hope you guys understand what's going on here. How do you know that it's 60? Okay, so it's geometry. The sum of angles in a triangle is equal to 180. And because all 3 lengths of the triangle are the same, it means that the size of all 3 angles will be the same because it's equilateral triangles. Okay, I understand, ma'am. Okay, perfect. So essentially what we have, all I'm showing you here is how we get from our equilateral triangle over here to this triangle that I'm going to use to determine my special angles. Okay, and this is my other triangle. Yes, you can use Pythagoras to find any unknown side only in a right angle triangle. Okay, I'm almost done. I just want to show you guys. It's really, really cool. Then, what I have over here, I'm just going to draw my 2 triangles. So this is my 1 triangle. This is my other triangle. You guys can learn these triangles, or you should 100% learn these triangles off by heart. Okay, so I have different ways to remember it. I just remember that opposite the 45s, I have 1. Opposite the 45s, I have 1. And my hypotenuse for this triangle is square root 2. So I just remember it off by heart. Opposite the 45, my length is 1. Opposite the 45, my length is 1. That's my first special triangle. For the second special triangle, hard guy, I know you say you lost, but basically all you need to do is memorize these triangles. Okay, they are shown in your maths textbook. So I'll just grab my maths textbook. There we go. They are shown in your maths textbook. And it says the following 2 triangles can be used to determine trigonometric ratios of special angles. Okay, so all you need to know is you basically need to screenshot this and study it. Okay, so this triangle, if you construct it accurately, you'll essentially get a 90-degree triangle, 45, 45. This side is 1, that side is 1. That is square root of 2. Okay, you also use that textbook. Awesome. Which textbook do you use? Okay, so at our school, what we teach our grade 10s with is mind action series. Okay, how did you get those values on the triangles? So you just have to learn it. It's mathematicians found it out, they developed it using accurate construction, and yeah, that's it. Okay, what grade is this? Grade 10. Okay, yeah, in this triangle, I can show you how we got that value though. We took this equilateral triangle, 2, 2, 2, dropped a perpendicular, essentially cutting the triangle exactly in half, line of symmetry. So that side is 1 and that side's 1. So there's my triangle, 1, 2. And to get this side, you can use Pythagoras. We know that that is 60 because it comes from an equilateral triangle. And we know that, remember, we're only looking at that part of the triangle. We know that that is 30 because it's this angle bisected, okay? Anyway, the point of this, guys, is, why is pure math so difficult? I'm sorry. The point of this is we need to learn, or you guys need to learn, the special angles. So I'm going to draw the table that I drew on my trig summary. And I do just want to emphasize something that's very important from that summary, just to avoid any confusion. Okay. Ooh, I'm going to need an extra column here. I'm being silly. Okay. My special angles are 30, 45, and 60. Sorry, those are supposed to be degree signs. Right. Now, they are special angles because I can use them to calculate the value of trig ratios. The following triangles can be used to determine the value of my trig ratios. Now, basically, what I do here is if I'm looking for sine, now everybody, if I'm looking for sine 30, here's 30. 30 is opposite over hypotenuse, 1 over 2. A half, okay? Sine 30 equals a half. Do you see? We didn't need to use our calculator. We used this, which is our special angles. Now, what is sine of 45? Sine is opposite, so 1 over hypotenuse square root 2. Now, in a summary that we use from my school, that we got from Advantage Learn, I don't know if you've heard of Advantage Learn, what we essentially show the learners that you can do is you can rationalize this so that you get rid of the square root 2 under the fraction. Basically, what I want to show you guys is 1 over square root 2. If I multiply something by 1, do we all agree that it's keeping it the same? Yes. So if I multiply 1 over square root 2 by square root 2 over square root 2, how to do this is another lesson entirely. But do you agree that square root 2 over square root 2 is the same thing as multiplying by 1? Check here. 1 over square root 2. Okay? If you type that into your calculator, it gives it to you in its rationalized form. However, if you are using and which you should be doing, by the way, if they tell you do it without a calculator, you should be using your triangles. Now, in old textbooks, I've actually personally myself, in old textbooks, seen them rewrite this triangle as square root 2, and 2. We would prefer you to use this one, which is in our current textbook. Okay? How we get this value shown on the calculator. See, 1 over square root 2. How we get square root 2 over 2 is we rationalize it, so we multiply it by 1. This is the same thing as multiplying it by 1. If you multiply the numerators, you get square root 2. If you multiply the denominators, you get 2. And that's where your calculator gets it from. Now, at a matric level, if you show them the rationalized version, which I put in my summary, you will not necessarily not get the marks. However, and I don't mark at a matric level for maths, I mark at a matric level for science. However, if you, and I spoke to a colleague of mine that does mark maths up to matric, if you show your triangles and you show that you've rationalized on paper, you show the method, they have to award you the mark. But why would you go through that effort? It's programmed in me to do it because that's how I learned it at school. However, if you, sorry, I know it got very dark. It is a bit of a mission to do it. So essentially what I'm trying to say is if you don't want to show it, sorry, I'm just plugging in my charger. If you don't want to show it, if you don't want to rationalize it, if you don't want to go through that effort and show you're working, then you leave it as 1 over square root 2. Do you guys understand what I'm saying? And how do we get 1 over square root 2? 45, sine 45 is opposite, which is 1, over hypotenuse, which is square root 2. I hope that makes sense. Okay, this is grade 10. Then sine 60. Look at 60 on my special angle. Please ignore my charging cable. Okay. Cos of 45 equals square root 2 over 2. Exactly, Funky Brush. That's exactly what I was showing you. It is not incorrect to write it like that. So cos 45 equals 1 over square root 2. And if you rationalize it, you do get square root 2 over 2. However, you need to show on paper if you do that in the exam, which is obviously something that I didn't mention in my summary because it was a picture or video of my summary. It wasn't an explanation video. So it's not that what I wrote on the summary is wrong. It's just I'm writing it in a different format. Okay. Anyway, sine 60. 60 is opposite. So what's opposite the 60 in my special triangle over here? What is opposite the 60? Opposite the 60 is square root 3. And what is the hypotenuse? 2. Okay, so these fractions you need to know off by heart. Okay, guys. So, for example, if I give you a question like this, and we can do this in the test, I can say to you guys, calculate, this is a very easy one, calculate sine squared 30 without a calculator. Sine squared 30. How do I do this? Now, first of all, we know that sine squared 30 is sine 30 squared. Okay? But what is sine 30? You quickly draw up your triangle. You know that this is 30, this is 60, this is square root 3, this is 2, this is 1. Sine of 30, there's 30, is opposite, so 1, over hypotenuse, which is 2. So it's a half squared. And what is a half times a half? A half times a half is a quarter. Do you understand how to do that without using your calculator? Okay. So that is why we do special angles, and that is why we learn it like that. Okay, let's do the last, so we complete our summary. Cos, let's do cos. Cos of 30. No, please repeat. Okay, let me do it again. So if they ask you, I'm going to just do it in the back here, sine squared 30. Okay, the first thing that you guys need to understand is that if I say sine squared theta, that means sine theta squared. It's just written in a funny way, okay? It is the entire thing squared, not just the theta squared, okay? So essentially, what we're doing here is sine squared theta. Sine squared, sine, I'm just trying to type it on my calculator. Sine squared theta is a quarter. However, if I tell you not to use your calculators, you know that sine squared theta is the same thing as sine 30 squared. It's the same thing. It's just written like that, okay? Which means sine 30 times sine 30. But now you're not allowed to use your calculator to figure out what sine 30 is. So now how am I going to do this? If I can't use my calculator to work out what sine 30 is, now do I give up? No. What you do is you draw your special angle, triangle like this. And you memorize this guy off by heart. We go, that is 3, 2, 1. That's a square root of 3. Just take notes. Opposite the square root of 3, we've got a 60. Opposite the 1, we've got a 30. The 2 is always opposite the 90 degrees. Then, sine 30. 30 is opposite, so it's 1 over hypotenuse, which is 2. So sine 30 is a half. So it's a half times a half, and a half times a half is a quarter. That's how we do these things without our calculator. Okay, that's why I'm teaching you these special angles. Okay, let's finish this quickly. Cos 30. Where's 30? There. Cos 30 is adjacent. Adjacent is square root 3 over hypotenuse, which is 2. Okay. This makes so much sense now. Yay, I'm so glad. Okay. Cos 45. Again, if we use a special triangle as we learn it here, as it is in the book, we know that cos is adjacent. Adjacent to the 45 is 1. Next to the 45. Opposite. Opposite is 1. It's adjacent. 1 over hypotenuse. Cos is adjacent, which is the 1, over hypotenuse, which is the square root 2. Okay? If you rationalize it, you need to show you're working out, and you always need to draw your triangles, guys, if you want your marks. Just draw your triangles. I'm telling you, you're going to get marked down. Then, cos 60. Cos, over here, cos is, what is cos, everybody? Adjacent. What's adjacent to 61? Over hypotenuse, which is 2. Also, just take note, and this is for another lesson. Sine 30 is the same thing as cos 60. Sine 30 is a half. Cos 60 is a half. 30 plus 60 gives you 90. It makes sense. Adjacent is the line next to the angle. Exactly. So for cos 60, adjacent next to is 1. Hypotenuse is opposite the 90. It's 2. Okay, let's just do tan. Tan 30, tan is opposite, which is 1, over adjacent. What's adjacent to 30? Square root 3. Okay, 45. Tan 45. This is a nice one. I love tan 45. Opposite is 1, and adjacent is 1. So 1 over 1. What's 1 over 1? 1 over 1 is 1. So you can write 1 over 1, or you can write 1. Doesn't matter. Tan 60. 1 over 1, which is equal to 1. Tan 60. Look at 60. It's opposite, square root 3, over opposite, over adjacent. Adjacent is 1, so it's square root 3 over 1, or just square root 3. Okay, how are we feeling about that? Now, if you memorize your triangles, you will immediately know the table. Okay? If you memorize the triangle, you will immediately know the table. Me doing the table was showing you how to determine my special angles. Sine 60, sine 45, sine 30. Okay. You're doing a disservice by saying cos instead of cosine and tan instead of tangent. Yeah, I am aware that it is cosine and tangents and stuff like that. It's just out of habits, maybe bad habits. Okay, so how did you guys find that? Thank you so much for joining the live. Much better, ma'am. Okay, cool. So obviously we didn't get very in-depth with regards to the content, but I definitely introduced it. So I hope that when you tackle trig, you should feel, a little bit more confidence. It was okay. Can we get a YouTube video for us to practice? It was a great introduction. Thank you. You helped me a lot. When you're going live again, I learned so much from this live. Oh, guys. Thank you. Nikhil, hello. Please send the PDF. I can try and do that for you guys. Do you go live for grade 10 every day? No, I don't go live for grade 10 every day. I alternate the grades that I do lives for. So if you just popped in, and if you don't follow me, please follow me, because I do grade 8, grade 9, grade 10 lives for maths mostly, grade 10, 11, and 12 physical sciences. Can you show the textbook again? Yes, I can. It's this one. Whoopsie. Mind Action Series. This is my one. Sorry, I thought it was my teacher's guide for a second. It's not. Okay. Any other questions that you may have? Can you show the textbook again? Sorry. Do you know any TikTok teacher for natural sciences? So it depends on what section of natural sciences you're struggling with. I know Miss Angler does grade 8 and 9, the biology part of natural sciences. And because I teach physical sciences, I was thinking of doing grade 8 and 9 videos for natural sciences, but for the physics part and the chemistry part of it. You're literally going to be the reason I get a 7 this year. Oh, Nikhil, love. Okay, so Miss Angler, definitely for the biology part. I'm sure everyone knows her already. She's absolutely incredible. I love her. She makes me laugh. Yeah. Do you do physical sciences term 2 for grade 10? Yes, I do. I do physical sciences grade 10, 11, and 12. So if any of you are in physical sciences, share my profile, please, with your physical sciences friends. Best trig teacher. Oh, thank you. Share your profile with my profile with your friends. For grade 12s that do physical sciences, I will be doing a lot of YouTube videos for you guys. Grade 12 is obviously very important. I will do other grades as well. But, ma'am, can you do a YouTube video for physical sciences grade 11? Yes, of course. I do have already on my YouTube channel. Let me just write my YouTube channel here for you guys. I do have some... sorry. Oh, that was very unattractive. Okay, maths. So my YouTube channel is Maths and Science with Miss M. Maths and Science with Miss M. So, yes. Please, physics. Ohm's law is part of term 2. Yes, it is. Grade life sciences teachers, Miss Angler, 100%. My YouTube channel, this is my YouTube. I should write there. YouTube. It's also linked in my bio, guys. YouTube. Okay. My YouTube is Maths and Science with Miss M. When is grade 11 physical sciences? Can't wait for you to get verified. You deserve it so much. Thank you so much. That's so nice of you guys. Really, I appreciate you guys so much more than I can even begin to explain. You're biting the pen like an animal. Oh my gosh. Where can we get your recordings? So I'll post them on my YouTube channel. Okay. Currently struggling with organic chemistry. I do have a few videos on organic chemistry. Watching from Germany. Wow, that's incredible. Hi. That is so awesome. So guys, please remember to share my videos and my profile with your friends that do maths and science. My YouTube channel is going to be a big focus of mine this term because yes, you can teach on TikTok. And yes, you can upload videos, short videos. Is term 2 grade 10 physics fun? Yes, it is. You can upload short videos. Hi from Belgium. Oh, that's awesome. Hi. Okay, so TikTok allows you to upload short videos. I can do short notes. Primarily due to your videos, I got 89% for physics. Oh, you guys are going to make me cry. So yeah, TikTok allows me to upload short videos and explanation videos and stuff like that. But I feel like it's the lives that really make a difference for people. So I'll definitely be doing more of it. And I absolutely love to talk to you guys. Let me keep this here. What's backwards? YouTube. I'm definitely going to be putting more effort and more focus on to my YouTube channel. What I've been doing is I've been doing TikTok because I absolutely adore making videos. I've always loved making videos. And when I noticed that people were actually learning from me, I was like, oh my goodness, this is so cool. I can actually teach people and I can use TikTok, which I find so much fun. Although be careful of TikTok. You can spend way too much time on TikTok, but I'm sure you guys know this. But anyway, I thought I can help people by making videos and doing what I love. And yeah, I got 70% for physics. I need to improve. That's why I'm watching your videos. Awesome. Well, I'm definitely hoping to help you guys more and more. To be completely honest with you, I'm going to try and put more focus. I watched some of your YouTube videos and I must say I kind of learned a lot. See, that's awesome. And I've barely posted on my YouTube because it's so, it's time consuming and I work a full job. I'm a teacher. As you know. So I teach at a school, and you guys, you go to school, so you know how it goes. You go to school, you have extramurals, which I also do. you also, and this is very important, you also need time for yourself. So you guys may like playing PS5, I don't know, games on your phone, whatever you guys like to do. And that's your downtime, and that's so important. I love to exercise, so I spend a lot of time running and all that stuff. So it's a lot, but I am super dedicated to being your teacher on TikTok. And I really, the fact that I'm helping you guys is the most important thing to me, because that's why I became a teacher. I became a teacher to help people. So yeah, it's really, really awesome that I have this opportunity. And I want to thank you guys for giving me the opportunity in the first place. So thank you so much for joining me today. I will love you guys too. I will communicate the date and the time of the next live. If you guys go to my bio, and you'll see like the little events like icon, that'll pop up if I've scheduled a live event. Hello. And I'll also be basically posting videos to say, listen guys, I'm going live on this day. So hopefully you won't miss it. Okay, when is the grade 11 live? I haven't set a date yet, but as soon as I do, I will communicate with you guys. Okay, it'll probably be a physics live next. So before I go, which grade for physics should I start with? Comment now. I give you a minute and then I'm gonna go. Oh my gosh. Yeah, so comment quickly. It's going to be a physics live, physical sciences, grade 11, grade 11, grade 12, grade 11, grade 12, grade 10, 12. Oh no, 12, 11, 10, 11, 10, 11, 10, 11, 12, 11. I think 11 is winning. Okay, guys, I don't want you to feel like I'm going to neglect any grade, because I won't. I will definitely be grade 11 deserves justice. Grade 11s deserve justice. I love it. And grade 12 is also very important. So is grade 11. So is grade 10. Everything's important. What am I saying? Okay. Right. I will be going live for all the grades. Don't stress for physics. Don't stress. Okay. Now, what I need from you guys is, do you know what topic you're going to be starting with in grade 11, 10, and 12? Because remember I told you all the schools do topics differently. So my request from you guys is, if you can, comment on, we're applying this year with grade 11, exactly. If you don't know your topics yet, as soon as you go to school tomorrow, and chemical bonding, that's what we're starting with. As soon as you go to school tomorrow and your physics or chemistry or whatever teacher says, listen guys, we're doing chemical bonding or whatever, or we're doing Ohm's law, we're doing, what are we doing with the matrix? Work, energy, power, whatever. You're going to comment on my TikTok video and be like, hey ma'am, I'm in grade 11 and we're starting with this. The way that that's going to help me is I'm going to see what I need to go live for. It doesn't help me to go live for something that none of you are doing at the moment. Okay. I think it's going to be chemical bonding for grade 11. For grade 10, it'll probably be electrostatics or electricity. And for grade 12, work, energy, power. That's what I'm thinking. Okay. Goodbye, everybody. Thank you so much. Sending my love. Enjoy the last day of holiday, okay? Bye, everyone.